Hello friends, today's question. Let I be the moment of inertia of a uniform square plate about an axis AB that passes through its center and is parallel to two of its sides. CD is a line in the plane of the plate that passes through the center of plate and makes an angle of theta with AB. The moment of inertia of the plate about the axis CD is equal to. So we are given a uniform square plate and there is a line AB axis rather which passes through center of the plate. So this is center of plate and this line is parallel to two sides, that is given as AB, and there is a line CD which is also in the plane of the plate and it passes through the center making an angle of theta with AB. So we have a line CD which passes through center. So this is CD, passes through center making an angle of theta with this AB. And we are supposed to find out what will be the moment of inertia about CD. So in this case, you can say we are going to use rather a theorem of perpendicular axis. So we have AB as one of the axes. Let us draw another axis which is our EF, and EF and AB are perpendicular to each other. Okay, and there is a third axis which is perpendicular to both AB as well as EF, and let us draw it like this, and this axis is suppose GH. So in this case we are given an axis AB, so we draw another axis EF which is perpendicular to AB but in the same plane. You can say draw axis EF perpendicular to AB and in the, we can say, plane of the plate plane. And we also, you can say, constructed another axis GH which is perpendicular to both AB and EF but not in the same plane. Draw axis GH such that GH is perpendicular to AB and GH is also perpendicular to EF but not in the same plane, but not in the, you can say, plane of the plate, not in the plane of the plate. So here basically what we did, we were given that AB, and let us say that this AB is a representation of x-axis, and we constructed EF, and this EF is nothing but with respect to y-axis, and then we constructed GH. This GH is nothing but with respect to z-axis. So now we have three axes which are perpendicular to each other, AB, comma, EF and GH. So AB and EF are in the same plane, whereas GH is perpendicular to both AB and EF but in different plane. So we can say for AB, let us write its moment of inertia is given as IAB. For EF, it is given as IEF, and for GH, we are writing it as IGH. Therefore, by theorem of perpendicular axis, theorem, we get IGH will be equal to sum of IAB plus IEF. Now, it is a square plane, and all these axes are passing through the center of mass or center point. Therefore, this AB is nothing but a symmetric. Sorry, not AB, but this square will be having a symmetric moment of inertia along all the axes. Okay, so we can write for symmetrical square, IAB will be equal to IEF. Therefore, we are going to substitute. We get IGH is equal to IAB plus IAB, which is equal to twice IAB, and we are given that IAB moment of inertia along AB axis is given as I. Therefore, we can say that our IGH is equal to twice of I. Let this be question number 1. Now, once again, we are going to construct another, you can say, axis or line which is perpendicular to CD. Okay, so we are going to construct a line, and let us call this a JI, and this JI is perpendicular to CD. Okay. So now we are having, you can say we have basic, this is our AB, and this we had as EF, and we were having a CD. This is our CD, making the angle of theta, and we constructed a axis which was GH, and here we constructed another axis or line which is JI, and JI is perpendicular to CD. We say consider an axis JI such that JI is perpendicular to CD and in the plane of plate. So basically means except GH, all the axes or all the lines are in the same plane. You can write it here, except GH, all the axes. So all the axes here means that our AB, EF and CD, and we are left with JI, are in the plane of plate. So they are in the same plane. So we can use theorem of perpendicular axis for, so we have this as JI, and this we have as CD, and they are 90 degree, and we have another axis which is not in this plane, which we called as GH. Okay. So we can use theorem of perpendicular axis. By perpendicular axis theorem, we have our JI, we have our CD, and we have our GH. So moment of inertia across JI, let us call it as IJI. Across CD, let us call it ICD, and across GH we get is IGH. So once again, by this theorem, we can write that our IGH is equal to I of JI plus I of CD. So once again, because of the symmetrical square, you can say but IJI is equal to ICD. So you can say that IGH is equal to ICD plus ICD, or this is equal to twice of ICD. So let me write it again. So we get this as IGH is equal to twice of ICD. Let this be equation number 2. So using equation 1 and 2, from equation 1 and 2 we get, so your left side is same, IGH and IGH, so therefore we can say that twice of ICD will be equal to twice of I. So here 2 and 2 cancels out, and we get moment of inertia along axis CD will be equal to I. This is the moment of inertia about axis CD. Therefore, the correct option is option number A. So we can say that option A is correct. So this completes the question. Thank you.